blow molded cases. Buy anything these days and they seem to come in a blow molded case. All different shapes and sizes. Why we can't standardize on this, I don't know, but this is only a very small part of my collection. The more modern cases are made better than they used to be. This is a more modern one. It still has a plastic hinge, but it does have a catch on the front, which lasts longer potentially. The cheaper cases, they have these clips, which stress here and can break, and also has a plastic hinge. And you've got a really old one here. Actually, these catches have stood up very well. This is easily 20 years old. It's an engraving tool. But they break. So the inevitable's happened. The tab has broken off my blow mold case. This is the cheaper style of blow mold case, and this commonly happens. The plastic just weakens over time and will break away. Same thing's happening to the hinge, but that's still holding up at the moment. This set is still useful. It's got an assortment of different specialist bits, and the case holds them together well, so not to be able to use it would be a shame. So I'm going to try and make a catch for this, 3D printed with a print in place hinge. And this is the 3D printer I'm going to use. As featured before in some of my videos, it's a Bambu Labs P1S with the 4-colour ANS on the top there. A good printer, you can concentrate more on what you're actually designing rather than the printing process, which I like a lot. Can't recommend it more highly. Okay, so I designed this in Fusion 360 with the print in place hinge, and as you can see it's worked quite well. And also did this case with a hinge with a shorter tab. I think it worked quite well. I'm pleased with it. So in case you're interested, I'll show the design process in Fusion 360 and explain how to create a print in place hinge. So I'll load Fusion 360. Fusion 360 has a fairly steep learning curve like most 3D CAD programs, but it is worth doing. There are several others available, such as FreeCAD and others, but this is the one I concentrate on. Start by selecting Change Parameters up here where it says FX. You click the plus icon there, and then a new parameter will show, and we can start entering our details. The width, I think we'll make 29. These dimensions should make a bit more sense as we go along. The hinge plate, I'll call that the hinge plate length. That's the plate that attaches directly to the case with the screws. It can be 23. What else do we need? The thickness of the material, 2 mm. And then clearance, I'm going to set clearance at 0.4. 0.2 is the minimum you would go with clearance, but 0.4 would be adequate for. And we'll set the size for the hinge pin, 3.5 millimeters, I think, but we could change that. And then we'll call this one hinge barrel. That's the outer round part of the hinge, and make that 8, I think. So I can't think of any others, so we'll go with that. Okay, so we start a drawing, stick that on the front, and draw a rectangle, and use the hinge plate length for its length, and obviously for its width we'll use the thickness, which is set as 2 millimeters. Okay, that's that. So next we're going to need a guideline to take us to the center of the hinge pin, and I'll use hinge barrel divided by 2, and then the circle. Whoops, set it. There we go. and that's what I called the barrel, hinge barrel, which was 8. Okay. And then we'll extrude that using the extrude tool and then pull it out to the width. So just type in width, and there we go. So that's one side. So what I'll do is turn that into a component. Hinge plate, we'll call that one. And then copy it. So better save the job first, I think. Blow-mould case repair, something like that. Okay, now right click it, copy it, go to the top and paste new. So that creates a copy that won't be affected by any changes made to the original. And just turn it around 180, move it back out of the way. Okay, that's the hinge plate and the latch plate. So I'll just rename that latch plate. Okay, so we've got 2 components. Now I'll make the hinge. So to do that, draw a sketch on the end of the hinge plate. And use the hinge barrel as the dimension. We want to add some clearance here, so when it 3D prints it doesn't stick together. So I'll add our clearance value. There you go. And then do an extrude. So, but what I want to do is an extrude offset. So it's in the center of the hinge plate. Okay, so what we want to do is, I find it helps if you just move it slightly and then go here and select offset, and then we need to calculate our offset. So the offset is minus width divided by 3, gives us the offset, and then the distance to cut is minus width divided by 3. There we go, and that's done the cut. There we have it, and you can see there's a bit of offset there for clearance. So we do something similar on the other side. Draw a sketch, and then a circle, hinge barrel plus the clearance. And another extrude, but this time just from that side. And there we go, and that's just the usual width divided by 3. And then we need to do an offset for the other side, so I take the same sketch and the same drawing, and our distance this time, so offset, and our distance is going to be width, so minus the width. And the distance is actually width divided by 3 rather than minus width divided by 3, and that takes the other side off. Okay, switch off that sketch. So now we've got the 2 parts. Okay, now what we need to do is an offset for clearance. So anyway, that gives us some clearance. And now when I join it, do a joint, here we select center of that one and center of that one. They come together, but you'll see it's offset. That's not what I wanted, so I've got to move it back over by the clearance value. That works, it's fine. There, you got it, and I think you can see the clearance all around, but we still haven't done the hinge pin. Okay, turn off the latch plate and do another drawing on the end, and we do a circle for the hinge pin, and that's hinge pin diameter, and extrude it all the way through. Oops, what did I do wrong there? Oh yeah, try again. Extrude it all the way through. Bang, it's going to cut it, so I don't want that, I want to join. Okay, so there we have it. Now I've got to make the hole on the other side. So turn the joints off and we'll do a drawing on here. So we need to do the hinge pin, but then allow a little bit of clearance for printing. So draw a circle, hinge pin plus clearance. There we go. And then do an extrude, push that all the way through. Okay, put the other side back on, and then we'll do a quick section analysis. And you can push it, oops, push it through to the middle. Okay, a bit of the other side there, you can see the clearance. And of course we can modify that value if you want to, and it'll, because of the nature of Fusion, it will actually update it for you. So there it is. All right. So the next stage is to create the latch. And also we'll do that on the latch plate end. Just looking back in the edit here, I made a mistake. I should really be working on the hinge plate component and not on the main body. It's just better, and this is wrong, but this will work, but it's not fundamentally right. Okay, anyway, here we go. So I'll draw some guidelines. And referring to a drawing that I've got here that I did by hand. It's just very rough, too embarrassing to show it to. It just tells me sort of, I mean, I'll still do it by guessing really. All I know is that I need to put a bend in the latch plate so that it actually hooks underneath the plastic part of the blow mold case. So I'll project that part of the latch plate into my drawing and turn off the body. It's just a bit easier to do it when you don't see the body. And referring to my hand-drawn sketch, just to give me some reference, I decided that was going to be 9 wide, and I need to put a bend in the latch plate so that it kind of hooks underneath the plastic part of the blow molded case. A short kick down. And that's come out at 165 degrees, not planned, but I'll copy that here. Type that in wrong. There we go. Okay, and then we'll make that 11 long, I think. There we go. And then another line. Make that 157 degrees. let me need this. It should make sense in a minute. An angle of what? Be a bit more acute than that, just to get room. So because I've got to make a pocket in the in this part. That should work. 170 degrees with a length of 12, I think. Yeah, length of 12. Drawing's becoming quite confusing, but then I'll just join them with an arc. These are the two ends here. 1 to 3 point arc. Something like that. Now that's not a constrained line, but I don't know how to do a constrained line there. I'm not quite sure what I have to do. I think it would be constrained off those two other points, but doesn't appear to be. Bit of a mystery. If you know the answer to that one, let me know. Still not constrained. Anyway, go to solid and we'll extrude what we got. So what I want to extrude is that. I don't want that, I don't think, do I? Yeah, I'll do that. Okay. Turn the body back on and then do it to the width and then join it. Okay, there we have our latch. Pocket's a little bit tricky to conceptualize, but it needs to be at an angle within here. So we do another drawing and I'll project that onto a new nice clean drawing. Do a line from here and we'll make the angle something like that. This does not have to be perfect, it's just what looks right, really. But we do want a kind of a hook, so the hook I'm going to form from here. Something like that. Whoops, that's too long. Like that. Okay, now I've just got to join those two up at the top there. Put another arc in. That'll do it. Now, yeah. And we'll extrude that offset, so finish the sketch. That's what we're going to do. So I'll just extrude that, but we'll extrude it in from the beginning, so it creates a pocket, gives it a little bit more strength. Offset, and we'll offset it by 4, and then so we need to bring it in, so it's this is the distance to extrude it, so it's the width minus 8, I think. And there you go. And now you can see we've got a bit of a pocket happening there. So turn the other side on, we're almost there. Just got to neaten it up a little bit and put some screw holes. And that will be our latch. So around the corners. Just take a guess, 4 is always a nice number. And then draw a sketch on the top for my holes. line. Turn the guidelines on, put it somewhere there. Again, a bit of a punt really. And just draw a centre line. Okay. And then we draw a circle. I'm going to put it anywhere. Make it 4.5 mil. Now you should constrain that really. I get a bit slapdash, but just do a mirror image of it. They're blue because they're not constrained, so if you resize the model they're going to be weird. So I'd say reference them off. Okay, now just one last thing to do. If I don't take this corner off, then it's going to mean that I can't bend the hinge back on itself slightly. So we need to put a line across there and just extrude it out all the way back to there, cut it off. Turn that drawing back on, and then we'll offset that to the other side. So I'll go offset width minus width, and then the distance, spin it round, is to here. Okay, so I've cut the corner off. Turn the model back on, you can sort of see what I mean, I think. If that pointy bit was there, then it wouldn't bend back on itself. So we want to export it, and I'll export it as a step file. That should be done, and then we'll go to Bambu Studio and import the model. Change the colour on, I'm going to have that grey. Okay. And then slice it with supports. I'm using tree supports, so I tend to prefer those. Don't really need that centre support there, but it's doing it, so I'll let it get away with it. And we send it to the printer. And that's going to take 22 minutes by the looks of it. So here it is, just finished printing. I'll take the build plate out and we'll take it over to the bench and I'll see how it came out. So it just breaks off pretty easily and supports come away. And you just bend it to see whether it's going to... There we go, snap. Now you've got a perfect hinge. Okay, now is it going to fit? I've got a feeling this is going to be too big. But let's see. So I had you can see on there I've tried to do this a different way before. So yeah, it's too big, so I'm going to have to make it smaller. So having modified it in Fusion and reprinted it, I've got this. Let's just see. Yeah, it's going to be perfect now. So I'll just put in the self tappers. There we go. That should be good enough. And it clips nicely, lovely. You can tell. So the sound it makes when I opened it up, then that's the sound we're looking for. Clip. Cool. Okay, going to call that a success. So if anybody ever makes it this far into this video and is interested in the design of this clip, let me know and I'll put it up onto Thingiverse or Maker World. Thanks for your time.